So I hope you understand the video, the basic principle of the vapor compression cycle. In that video, basically, if you recall, basically there are four major components of the vapor compression cycle. One is the evaporator, where we place our items like milk, food, or we want to store certain ice. We divide the evaporator into as a refrigerator, freezer and refrigerator, where we want to freezing. So the first portion, the top portion of that evaporator, we normally called it as a freezer. The lower one we called as the fridge. And the heat is transferred with the help of a fan from top to the bottom. Now in case of evaporator, the refrigerant, liquid refrigerant, here is the liquid refrigerant, let's say at minus 20 degrees C, and at let's say 0.6 bar pressure, this pressure is a gauge pressure, enters into the evaporator, so it absorbs heat. So that liquid refrigerant absorb heat from the evaporator. Now it will be in the form of vapors now, right? This is a vapors now, but this is a phase change process. So that means minus 20 degrees centigrade, again the temperature will be constant because this is a phase change process. So constant temperature, right? So all the heat from the evaporator is absorbed by that liquid refrigerant. Now it is converted into vapors. Now in order to make the process a cyclic, we need to increase the pressure, so that low temperature vapor, they are introduced into the compressor. Now the compressor compresses the vapor into a high pressure, normally at 8 bar normally. So from 0.6 bar to 8 bar, the pressure is increased in a compressor. So if you increase the pressure in a compressor, the temperature also increases. Normally that temperature is around 80 to 90 degrees C. So let's assume the temperature is 90 degrees C. So these high pressure, high temperature vapor enter into the condenser. Now the heat absorbed from the evaporator and heat taken as a result of the compression process need to be rejected from the system. So that heat we need to be rejected from the condenser. In condenser we can use a fan, or we can use the simple environmental condition, the ambient air, to cool down the high pressure and high temperature vapor. So once it passes through the condenser, then at outlet, that the vapor is converted into liquid refrigerant, let's say at 45 degrees C, right? At 45 degrees C, but the pressure is still very high. At outlet the pressure is still 8 bar. So that means we should have a device which decreases the temperature, further temperature, as well as the pressure of the high pressure liquid refrigerant. So we use a device we call the throttling device, sometimes we call the expansion device. It is just like a capillary tube. So in capillary tube, what happens, because of the expansion of the high pressure liquid at outlet state, we got very low pressure now. So the pressure decreases from 8 bar to 0.6 bar, and as a result of the decrease in pressure, the temperature also decreases. The temperature becomes minus 20 degrees C. So now this process keep on continue. This is a cyclic device. So you give input to the compressor, so you got cooling effect in the evaporator. Then we discuss different innovation in modern vapor compression refrigeration system, and out of those innovation, one of them was a defrosting, compact condenser, throttling device, and inverter. In case of defrosting, as you know that in defrosting, when you open a refrigerator, then air enter into the refrigerator. So along with the air, there is chances of moisture also enter into the refrigerator. So the moisture, because inside the temperature is lower, so that moisture content, they are condensed and eventually it become ice, and with the tube, the refrigerator tube, it is deposited with the passage of time. So the efficiency of the refrigeration system decreases, because the heat transfer from the items placed inside the evaporator to the tube is decreases, so the efficiency is a decrease. So how can we defrost that? The defrosting is carried out with the help of using that heat of the condenser. So we use a metallic rod which is placed in front of the condenser. So the heat from the condenser is taken by that metallic rod, so that metallic rod move through into the evaporator, right? So that means the heat, because this is a conductor, so that heat taken by that conductor is eventually gone here. So with the passage of time, that heat, which is the ice deposited on the tube, it is eventually melted, and then we place a simple tray at the lower end of the fridge so that vapor are collected. And then the second innovation is compact condenser. So instead of using old condenser at the back side of the fridge, which is like the bending of a very long condenser tube, we can use a compact condenser as you see in the video. And the third innovation was a throttling device. So instead of using a capillary tube, we can use a long tube, right? A long tube. Now what is the advantage of using a throttling device as a long tube? Because we can make sure we can increase the life of the compressor, because we want to make sure that the refrigerant entering into the compressor should be in vapor phase. It should not be a mixed phase. If the mixed phase enter into the compressor, then the life of the compressor decreases. There are chances that it can damage the compressor. Then what we do? Then we do, like, if the throttling device is a long tube, then we try to make the thermal contact of that point 4 with point 2. The objective of the point 2 is take heat. So it should show so that these vapor become pure vapors, so that heat can be taken from point 4. Whereas the objective of the point 4 is to decrease the temperature. So that means here the temperature is -20. So that temperature is given to that point 4 and the heat is taken from point 2. So that the vapor entering into the compressor is pure vapor. And the last innovation was inverter compressor. In our old refrigerator we had single speed compressor. Single speed compressor mean it can be turned on and it can be turned off. So that means it is operated at constant speed, right? So constant speed compressor cannot control the temperature efficiently. It takes very long time to come into equilibrium state, whereas the variable speed compressor, which is also called inverter compressor, which we give the first we convert the AC supply into DC supply. So hence DC supply, with the help of DC supply we can operate the variable speed motor, and hence variable speed compressor. So the control of the temperature using the inverter is very very good, and as a result the cost of the electricity is also very low, because if the control of the the setting of the temperature is low temperature, then the speed of the compressor will be lower, hence the input to the compressor, the electricity will be consumed less. While in case of constant speed compressor, the compressor has to operate at constant speed, so that means you cannot save the electricity. That's the end of this lecture number 2. If you could not understand, if you have any confusion, you can write an email, you can come in interaction session, or even you can call me. Right, see you in the next class. Thank you very much.